Hello, I'm sure all of you are doing fine. Now, as far as projections are considered, as far as projection is considered, we have seen the fundamentals of orthographic projection. Then we have seen how to get the projections of a point when in the given quadrant. Now, in our case, of course, it is always the first quadrant because we are applying the first angle method of drawing. Then, so we have started with a point which is a dimensionless element. Then we extended the idea, and so from a point, so we got set of points which is a line, and then we have understood the projections of a line. That means getting its front view, top view and the profile view in oblique condition, that means inclined to both the reference planes. So now we further extend our idea regarding projection. So we extend the idea from set of points to set of lines. So that means, like for a point, when I have say extended in this direction, so we got line as a single dimension element. So now when I as if I just stretch it in the another principal direction, if I say, so I give it a width or a breadth, whatever we can call. So here I am getting a two-dimensional element which is having two dimensions. So I can say this is set of lines, right? So infinite lines are there. Anyway, I can consider these lines. So we get this two-dimensional element called as a plane or a surface or a lamina. Right? So we will be most of the time using the term plane only. So now we will try to see how to get the projections of a plane, right? So this plane being a two-dimensional element. Now, as in case of the lines, we have seen certain specific conditions of a line, like line parallel to both the reference planes or principal planes, line inclined to one plane, line inclined to both the reference planes, that means the oblique condition. So similarly, in case of planes, we can categorize these two conditions, or maybe I can call some of the type of placements. The first condition is called as, or we call them as, the perpendicular planes. Perpendicular planes. Now we are here talking about the conditions, and the second condition of planes or their placement in the quadrant is called as the oblique planes. Now if we see the condition of perpendicular planes, to categorize them, first we can say that planes which are perpendicular to both the reference planes. Like in case of a line, we have seen that there can be a condition, or the most simplest condition for a line can be parallel to both the reference planes, as it did say, considering this as the line. So we can place it in the quadrant parallel to both the reference planes. Now when we take the condition of a plane, say here I have a plane for you, this is a hexagonal plane, right? So I can have this plane as it is a two-dimensional, so you can see it is having two dimensions, and the third dimension is negligible. So as compared to the dimension of the plane, the third dimension is quite negligible. So hence we are calling this as a two-dimensional element, right? So we can have this plane perpendicular to both the reference planes. Both the reference planes means for us it is the vertical plane and the horizontal plane. So I can place it perpendicular to both the reference planes. So in the category of perpendicular planes, we can have the plane perpendicular to both HP and the VP, the horizontal plane and the vertical plane. Now what can be the second case? Now second case can be where a plane, now at this condition, this plane is perpendicular to both the reference plane. Now keeping it perpendicular to VP or the vertical plane, I can make this plane parallel to HP, right? So I can have a plane perpendicular to VP and parallel to HP. This is the second condition. So it is perpendicular to VP. It is remaining perpendicular to VP, right? So if you see, it is remaining perpendicular to VP, but it is parallel to HP. Now what can be the second case now? I can keep it perpendicular to HP. I can keep it perpendicular to HP and I can make it parallel to VP. So third condition or third category in the perpendicular planes is where the plane or the plate or the surface or the lamina is perpendicular to HP and parallel to VP, right? And oblique planes, we know this condition. Oblique means when it is inclined to, this is the third case, sorry, there is a fourth case. Now, the case D, which I have missed. Now, wherein we can again have a fourth condition where this plane remains perpendicular to the vertical plane, but it is inclined to HP. It is not parallel to HP, it is inclined to HP, or this plane remains perpendicular to VP and perpendicular to HP and it is inclined to VP. So this third condition I can say where a plane is perpendicular to VP and inclined to, so it is perpendicular to VP and it is inclined to HP. And the fifth condition I can say, discretizing all the possible cases where a plane perpendicular to HP and it is inclined to VP. So the plane is perpendicular to HP but it is inclined to VP, right? So this is the fifth condition, and the basic categorization here can be what I have written earlier is the oblique planes. So what are oblique planes? It is quite obvious from the name we have given, where the plane is inclined to HP, right, as well as it is inclined to VP, right? So the plane is inclined to HP, fine, and it is inclined to VP as well, either this way or maybe this way, right? It will depend on what is the condition given to us in a given problem. So accordingly we will work out for the problem. So anyway, we can show it that it is inclined to HP and it is inclined to VP. So this condition of the plane when it is inclined to both the reference planes. So this is, so in this case the plane is inclined to both HP and VP. So in general we can categorize these conditions, and to reach to the final projection of this condition we will take help of somewhat these steps which we have just now understood. right? So let us begin with understanding how we get the images or projection of a plane and how we should work out for a given problem, right? So if we see the first condition for perpendicular planes, so we have taken a plane perpendicular to both HP and VP, right? So projection means we have to go for the front view and the top view, or the elevation and the plan, and if required we will go for the profile view. So say as we have seen earlier also, let us try to understand with a pictorial explanation. So this is the vertical plane and this is the horizontal plane, right? So this is vertical plane, this is horizontal plane. Here we will get the front view or the elevation of the plane, and here we will get the top view or the plan of the plane, right? So now if we see this condition where the given plane is perpendicular to both the horizontal and the vertical plane, or both the principal planes or the reference planes. So let us place it with the simplest condition. So I place it this way, where this plane, given plane, so I name it as A, B, C and D. Now again we will apply the same fundamental. When I wanted to project a line, what we did is we have projected any 2 points of that line on the required principal planes, and simply we have joined those 2 images of the points and we got the required image of the required line. So same fundamental will be here. So if I want to, like, even if I ask you to draw a square, what you are going to do? You are going to simply first mark the 4 corners, right? And you are going to join them together relevantly. That will give you the required plane. Now here, if you are going to join them without a meaning, right? So you are not going to get that plane in any way. So that coordination and understanding needs to be there. So that means one thing is clear. Even when I want to project a plane, I have to simply first project all the corners. Now these are called as the corners of the plane. Corners will be always the points, and these which we are calling the sides, they are also called as the edges. The edges. So edges are always lines. So if I want to get an edge or side of the required plane, I'll have to project the corners. Fine. So now we have kept this plane in the condition given plane perpendicular to both the reference planes. So as if I take this, here I have shown a rectangular plane, but here I have a hexagonal plane. So when I want to keep it perpendicular, even in the view, you will be able to see, when I keep it perpendicular to the vertical plane, you are able to see only the thickness of this plane. That means the image what you are able to see right now is just a line image. Fine. In whatever orientation I keep it. Here I have kept it with a very simple orientation. So we'll see if I change the things, how things are going to change. So anyway, I kept it in the simplest form, as if this edge BC and AD, which are parallel to each other, is as well parallel to the horizontal plane right now. So now for the 2 views, that means as an observer, for the front view, I'll be standing here and looking at the plane or the object, and for the top view, I'll be moving to the top and looking at the object from the top. So when we are looking here, so according to the orthographic projection conditions, the projectors will be parallel to each other, and they will be perpendicular to the plane on which we are taking the image. Now when we are taking the image for the front view, that means we will be passing projectors through all the corners, that is A, B, C and D. So projector for A, projector for B, projector for C and projector for D. So you can see when the element gets complicated or number of dimensions are getting increased, the complexities in the projection is also increasing. Complexities in the way the number of projectors are getting increased. Now we have seen in case of lines, we needed only 2 points on the line, so we had 2 projectors, like we have taken line AB or CD. So we have 2 projectors which we handled and we got the required image. But here now to get a square, I have 4 square or a rectangle, then it will be having 4 corners. So I will have to pass projector through 4 corners. Now if I have a hexagonal plate to have its projections, then from all the 6 corners I will have to pass the projector and get the image. So anyway, if we see this, so as I have told you that I have kept this edge BC and AD parallel to HP, that means they get perpendicular to the vertical plane. So I pass the projector through A, wherever it meets I will get the image of A. Then I will pass the projector of D. Now in this case, the projector of D will coincide with projector of A and I will get the image of A and D. So here, now when I am looking at it from this direction, I will be able to see D first, then A. So I will write this as D dash A dash. Similarly, for the corner B, so I am going to project the corner B. Right? Now wherever it goes and meets the vertical plane, there I will be getting the image of B. Then we will be passing projector through C, and definitely in this case it will pass through the corner B. So here I will be getting at the same place where the image of B is. So here again I am able to see C first, then B. So I will name this as C dash B dash. Right? So when I join A with B, B with C, C will be there itself and C with D. So I am getting the front view image as a line image, as I have told you here. Right? So you are able to see the front view image as a line image, and this being, say, the B and C, and this being the D and A front view image. So similarly, now when I go for the top view, so for top view again I will drop the projector for A and D. So from B I will drop the projector, and from A I will drop the projector. So wherever it intersects with the horizontal plane, I will be getting the top view image of B and A on the same place. So first I will be able to see B, so I will name this both images as B dash A dash, right? Then we will drop the projector from C, and then we will drop the projector from D. So wherever it intersects, the projector intersects or strikes the horizontal plane, I will get the image of C and D. So from looking from the top, I am able to see C first and then D. So it will not be dash, it is the top view, so it is BA, and this is CD. So when we join A with B, now A with B the same place, then B with C and C with D there itself. So when we join all these 4 points together, we get the top view image of the plane. So if you see in the orthographic projection, when I want to draw the orthographic projection of a plane which is perpendicular to both the planes, so say this is all the projectors of A, B, C, D, they are going to be one only in this case, right? So coinciding, all these 4 projectors, they are coinciding. So maybe if I know these heights and their dimensions, So we are able to see the front view image and the top view image of the plane as this, where this was B dash A dash and this is C dash B dash, and here we are getting B A and this is C D. Thus we get the right. Now if you see it in the profile view, so if I see it in the profile view, the profile plane is perpendicular to both the reference planes, right? So if I want to see the shape of this plane now in this condition, then in that case, in the profile view, I'll be able to see the image of this plane as this, right? So this is just for understanding how we can get the shape of this plane. Right now we will not be talking in details right now. We'll see in the sessions, coming sessions or coming situations, right? So here we are able to see the image of the plane as a line image, right? And this line image of a plane is called as the trace. So it is the trace of that plane. So trace of a plane will be always the line image. So when I keep it this way, right? And when can we see the line image? Only when the plane gets perpendicular to the reference plane. So if this line, if this plane gets perpendicular to VP, either this way or this way, then I'll be able to see its line image or the trace. Now this length of the trace will vary, or it can vary depending on the orientation of the plane in the quadrant. For example, in this case, if I keep this rectangular plane in this orientation, but it is perpendicular to, so let us say this is A, B, C and D, right? So when I pass the projectors through all the corners, so this is projector of A, projector of B, projector of C, projector of D. But as you know that we have kept the condition to be perpendicular to the vertical plane, that means all these projectors will be lying on the same plane, right? So even though the orientation is changed, we will get the image of this plane to be a line image only. But what will happen in this case? The trace. So how we are getting? This is projector of A, so this is A dash. This is projector of B, so this point will be B dash. This is D dash and this is C dash. So here the image has changed, right? Though we are getting a line image, but the length of that image has changed. That means the trace length will be a different length. So the length of the trace will definitely depend on the orientation in which the plane is placed in the quadrant. Similarly, it will be for top view also. So all the projector of A, B, C and D, they will be separated. So we will be getting a different length. Though the image will remain as a line image because the plate or the plane is perpendicular to the horizontal plane as well. Right? So it is horizontal. So when I am looking at it from the top, so I am able to see its line image, but the trace length is going to change. So that is how we understand. So this is one of the simplest condition in which a plane can be kept. So we can use this if required for achieving the final projection of the line. So let us move on to the next condition. So collectively I am taking this condition where a plane is perpendicular to one plane and parallel to the other plane. So condition can be the plane is perpendicular to VP and parallel to HP, or the plane is perpendicular to HP and parallel to VP. So when we have considered this was the first condition where the plane is perpendicular to both the reference planes. Now if I take the first condition, this being perpendicular to VP, just now we have talked about that when this plane is perpendicular to VP, so we will be able to see the trace of this plane in VP, that means in the front view, right? So keeping it perpendicular to VP, we can make this plane parallel to HP. So here again the front view image remains the trace length, and you are able to see that the trace has got parallel to HP. That means this plate has become parallel to HP. So this can be this condition. Second case, keeping it perpendicular to HP. So it is perpendicular to HP and I can make it parallel to VP. So the top view image is the trace image, right? And in the front view, you are able to see this surface of the plane. Now we will talk about the dimension as well. So let us try to understand again with the help of this pictorial representation. So when, say this is the first condition and here I will show the second condition, right? So this is the vertical plane, this is the horizontal plane, here this is the vertical plane, this is the horizontal plane. Now we are going to keep this plane perpendicular to VP and parallel to HP. So that means again I will consider the rectangular plate. Let us say this is this rectangular plate. Let us name this as A, B, C and D. So this plate is perpendicular to VP and it is parallel to HP. And the second case is that the plane is perpendicular to HP. It is perpendicular to HP and it is parallel to VP. So maybe this plate is kept this way. So now when for the two images as an observer, when we look at it from this direction, I'll get the front view, and then I look at it from the top, I'll get the top view on the horizontal plane. Right? So when we are looking at it from the front, so let us say again I have kept it in the simplest manner. So the projector of A and B, they coincide. So somewhere here I am getting the image of A and B. Then projector of D coincides with C because I have kept it that way. So I get the images here. Now when we say that this plate is parallel to HP, right? When this plate is parallel to HP, then all the corners of this plane will be at the same height from HP. That means the images what we have got here, so we're looking at it A first, B then, so this is A dash, B dash, and D first then C, so this is D dash, C dash. So when I join A, B, C and D, so I get the front view image, right, which is a trace image. So here the front view image is a line image and I am able to see the trace, right? Now as the plane is parallel to HP, the plane is parallel to HP, that means height of all the corners of this plane will be same. So that means height of A height of B, height of C, and height of D if it is h. So all these are having h height, right? Now when we go for the top view, so we will be dropping the projector from corner A, B, C and D. So wherever they intersect with the horizontal plane, so this is projector of D, projector of A, right? So this is A, this is B, this is C and this is D. So we join A with B, B with C, C with D and D with A. So we get this as the top view image where I am able to see the shape of this plane, right? Now as we have kept this plane parallel to the HP, that means all the lines contained by this plane will be parallel to HP. And in the projection of lines, we have understood that when a line is parallel to a plane, we get its true length in that plane itself. So that means if it is parallel to HP, so I am able to see all the lengths images to be the true images. That means whatever is length AD, this is dropped in the top view. Whatever is the length AB, that is dropped in the image. So here the same shape, whatever shape this is having, I am able to see this shape. So this is the true shape. The image is showing the true shape of the plane. And when this is possible? Only when the plane gets parallel to the reference plane. Now in this case the plane is parallel to HP, so I get all the sides parallel to HP, so all the side images are equal to the true length, hence I am able to see the true shape of this plane, right? Similar can be applied here. So if you want to see what can be orthographic projection for this one, so this is the reference line XY. So we have seen that we have kept BC and AD, which are parallel to each other, to be parallel to VP. So that means I am able to see the true shape of the plane on the HP. So we have got this as A, B, C and D as the top view, and when we draw the projector for, so to get the front view, we will be, so I want to achieve the front view, so projectors are to be taken to the front view. So projector of A, projector of B, projector of C, projector of D. So and A, B, C, D will have the same height. So I get the front view image of this plane to be as A dash, B dash and D dash, C dash. So this is the orthographic condition. Now why we are getting the true shape here? This is because plane is parallel to HP. Now how I am ensuring that plane is parallel, or rather we know, so we have kept this condition perpendicular to VP and parallel to HP, right? Now we will be utilizing this condition because the trace can predict or can give me the inclination of this plane with respect to the given plane. So we are going to use that. Now if we see in this condition what we kept, we have kept this plane parallel to VP. So we have kept the plane parallel to VP and it is perpendicular to HP. So as this plane is parallel to VP, right? As this plane is parallel to VP, we will be able to see the true shape of the plane in the front view, but the top view image will be the trace image. Now why this condition is important is that we are provided with the inclination of the surface, and as you can see here, if I want to give this surface an inclination of say theta with HP, it will be very comfortable, or we can give inclination only to a line. So my objective will be to see that plane as a line image so that I can put the inclination. So I have to ensure that I make this plane perpendicular to one of the planes. And how I can ensure? If I make it parallel to one of the planes, then automatically it will get perpendicular to other. So if I make it parallel to HP, I ensure that it has become perpendicular to VP. If I make it parallel to VP, that means I have ensured that this plane has become perpendicular to HP, right? So as we will be knowing the conditions of the plane, so if I am drawing the true shape of the plane, if I am drawing the true shape of the plane in one view, that means the other view must be the trace, right? And the inclination to the surface can be given only with the help of the trace. Fine, that we'll see in the coming section, next condition. So here we have kept it parallel, so the projectors will be, right? So I'll be able to see, in this case, true shape in the front view, right? And the trace image in the top view. Again, it will depend on the condition of the orientation I have. That this trace length is again going to depend on the condition of the orientation in which it is kept in the first quadrant. So the orthographic image or orthographic projection in this condition, now in the front view we are able to see the true shape. So if I want to ensure for the trace, so this is, let us say, A dash, B dash, C dash and D dash. That means if I draw the true shape in the front view, I am ensuring that it has become perpendicular to HP. So the corresponding view will be definitely a line or trace image of the given plane. So I get this image as this. So for this I am looking at it from the top. So B first, A then, so it will be BA, C first, D below that, so it will be C, D. So thus I get the top view image of this plane. So that is how this condition is there. So fine. So orthographic projection for this condition will be this, and orthographic projection for this condition will be this. So wherever we see the true shape, so true shape is seen in the front view, that means the plane is parallel to VP. So obviously the top view will be a trace. If I draw the true shape in the top view, that means obviously the front view will be a trace. And we utilize these conditions to solve the oblique condition of a given plane. So let's see the next condition now, where a plane is perpendicular to one of the reference planes and it is inclined to the other plane. So as if you see, this is perpendicular to VP and this is inclined to HP. So the plane is perpendicular to VP because you are able to see the trace length, and it is inclined to HP. And the inclination of this plane is given by the trace of this plane. Similarly, second condition, it is perpendicular to HP, so it has to be perpendicular to HP and it is inclined to VP. So in the top view I am able to see the trace length, and this trace is giving me the inclination of this surface with the vertical plane. So that is why the trace image is important for us. So say for this condition, the plane is perpendicular to HP, so maybe it is placed in this fashion and it is kept this way, where it is inclined to it is inclined to VP, and inclination with VP, the true inclination with VP is called as the phi. So this plate or the plane is perpendicular to HP and it is, so let us name this as A, B, C and D. So it is perpendicular to HP, it is perpendicular to HP and it is inclined to VP. For this condition, it is perpendicular to VP. So let us say it is placed in this way, right? And it is inclined to HP, and inclination with HP is theta, right? So say this is A, corner B, C and D, right? Now let us see what can be the projection. Now as this is perpendicular to HP and it is inclined to VP, so when we drop the projectors, so projector of A, projector of B, so they will be coinciding, so image of A and B will be same. So this is BA, and somewhere here it intersects with, so this is CD. So as this plane is perpendicular to HP, we will get the top view image, the top view as the trace, right? And this top view or the trace will be inclined at phi. So it is perpendicular to HP and it is inclined to VP. So when I am looking at it from the top, I am able to see its inclination with VP. Let us talk about the front view. So now front view, for front view, again we will pass the projectors through all the corners. So this is projector for A, this is projector for B, this is projector for C, and this is projector for D, let us say, right? So say I get the image of A here as A dash, image of B here as B dash, image of C here as C dash, and image of D here as D dash. So when I join A, B, C and D, I get the front view image of this plane, right? Now here you will see that the edges B, C and AD, they are inclined to the vertical plane, and we have seen in the projection of lines, when a line is inclined to a plane, we always get its projected length. That means this B dash, C dash length and this A dash, D dash length. So this front view length of these two edges, it is not equal to the true length, right? If it is so, that means this is not the true shape, or this shape we are getting this to be as the projected shape. So this is the projected shape. This is not the true shape. When this is happening, when the plane is inclined to the reference plane, it can be anyone, the vertical plane or horizontal plane. Let us say this case. Now if I keep it parallel to VP, right? So if I am keeping it parallel to VP, as if now you are able to see the true shape. But when I make it inclined to VP, you are able to see a more shrinked image of this plate. So this is not the true shape which you are able to see. Rather you are able to see the projected shape. Why it has happened? Because this has become inclined to the vertical plane, right? So the orthographic image of this will be, I am getting the trace to be inclined at phi, right? I am getting trace to be inclined at phi. So this was BA and this is CD. So when we are projecting, so as if I know what is the height, so I am getting this image to be as B, A, C, D, right? So, sorry, A, B, anyway, so we are getting this shape to be as a projected shape in this case. Now for this one, if you see here, in this case, this is perpendicular to VP and it is inclined to HP. So here you are able to see this trace to be inclined to HP, right? So if we project for the front view, we'll see that projector of A and B, projector of C and D somewhere here. So we get the front view image as the trace image, but the trace is getting inclined, or it is inclined at theta. So this is A dash, B dash, this is D dash, C dash. So we are getting the trace to be inclined. So when we drop the projector for the top view, so we are able to see the top view image to be this, wherein in this case again, as you see, the edges AD and BC, they are inclined to HP, so their projected lens will be transferred to the top view. So we are getting the top view image to be a projected shape. So the orthographic projection for this condition will come out to be the trace to be inclined to the XY line by theta, where this is A dash, B dash, and this is D dash, C dash. So when we drop the projectors for A, B and C, D, so this is A, B, D and C and D. So D for C, right? So here we are getting this as the projected shape, right? So this is not the true shape. Now why these steps are important for us to understand is because we are provided with simply the conditions of the plane. Say it is inclined to HP by some theta, and the plane is inclined to VP by some phi. So we cannot put both these inclination together in one step itself. So we have to put it step by step. Even if I ask you physically that place this plate or plane inclined at theta to HP and phi to VP, directly you cannot put it in that condition, right? So anyway, you will have to ensure first the theta and then the phi, or first phi and then theta, right? So in the similar fashion, for solving oblique condition, we have to go through these steps, and we have understood from this conditions that the inclination can be drawn with the help of a line only. So the trace is a line image of the plane, so it is important for us to get the trace first. So how I can ensure to get the trace? Now trace can be achieved only when the plane is perpendicular to the reference plane. So if I want to have the trace in the front view, that means I'll have to make it perpendicular to VP. So how I can ensure? I'll make the plate parallel to HP. So the moment I make the plate parallel to HP, it will get perpendicular to VP, and if I have to put theta, then I can give this theta to the trace and get the projected shape, right? Similarly, if it is said that the plate is inclined at 5 degrees to the VP, that means I have to give this incline phi is visible in top view, right? That means I must be seeing the trace, because I have to draw phi. So phi is to be drawn in the top view. That means I want the line image in the top view. That means I'll have to ensure that I make this plane perpendicular to HP. Then only I am able to see the phi, because phi will be able to see in the top view only, right? So how I can ensure? So in the first step, I make it parallel to VP so that I am able to see the true shape. Then I will be able to see the trace, and then I will give the inclination, trace inclination, and I will get the required image. So we will see how we can solve a problem with the help of these conditions. So that is all in this session.